Hey, geometry students. In this lesson, we are going to be talking about how we can apply similarity, the concept of similarity, to similar polygons. Now, a future lesson, we're going to learn some theorems or postulates related to which kinds of polygons are similar. Just like we have our triangle congruence theorems, we're going to develop some triangle similarity theorems and postulates. But that's not this lesson. For now, all we're going to do in this lesson is extend the lesson that we've had previously on proportions and talk about how we can apply proportions to similarity in general. Let's get started. We're going to start with a theorem. Theorem 44.1 states that if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. So we already know that if two polygons are similar, then the ratio of their corresponding sides is equal. If I divide one corresponding side in one figure by the corresponding side in the other figure, that ratio is really important. That's one of the things we're going to be using a lot in this lesson. What this theorem says is that also applies to perimeters if we add all of the sides together. And the fact that this is a theorem proves that this indicates, I suppose, that this can be proven. All right, let's get started with our lesson practice. We're just going to dive right in today. We're not exclusively going to be using this theorem, but we are going to use this theorem in our lesson. So pay attention as we do that. Letter A, triangles JKL and FGH are similar. So that's a given. Now I need to find the values of X and Y. The starting place for a lot of these problems is to find the similarity ratio for our figure. And in this case, my similarity ratio is going to be found from the side that we know in both figures. I know KL is 11 in this figure, and I know the corresponding side. Okay, so I know this and the corresponding side, so I can figure out the similarity ratio. And if I'm comparing my first triangle to the second triangle, that similarity ratio is going to be 1 to 3. By the way, if I was comparing the second triangle first, and I was using these values first to compare to this triangle, I could use 3 to 1 as my similarity ratio, as long as I use these sides first and these sides second. But notice, I'm picking the left triangle first. I'm putting 11 in the numerator, and then I'm picking the other triangle second. I'm putting 33 in the denominator. So this is an 11 to 33 ratio. That simplifies to 1 to 3. Okay, now I can set up a proportion using this. 1 to 3 is going to equal, and then on my other side, I need to find x. I notice that x corresponds to 21 if I look at the corresponding side in this triangle. How do I know that these are corresponding sides? Well, JKL. JK were the first two letters in my first triangle, so they're going to be corresponding to the first two letters in the second triangle, FG. So x corresponds to 21. And how does it correspond? By the same ratio, x to 21. 1 over 3 equals x to 21. All right, now to solve this, I just need to cross multiply. I'm going to multiply the numerator of the first fraction by the denominator of the second. It's going to give me 21 equals, and then the denominator of the first fraction by the numerator of the second, 3x, x equals 7. Okay, that's x. Now, what about y? Same sort of thing. I need to, first of all, the similarity ratio is going to be the same, 1 to 3. But now, instead of using the side length 21 and x, I'm going to use y and 27. Which one do I put first on top? I need to put the one from the left triangle on top because I have 11 on top in my first similarity ratio. So this is going to be y to 27. Okay, cross multiply. If I cross multiply here, I'm going to get, let's see, 1 times 27 equals 3 times y. 1 times 27 is 27. 3 times y is 3y. And then it's pretty easy to figure out here that y equals 9. All right, I've got x and y. I should probably just double check that I got these correct. There we go. All right, let's move on to the next one. In triangle ABC, AB equals x squared minus 7, BC y plus 4, and CA 5. In DEF, notice that they're listed in the same order. AB was first, now DE is first, 6, EF 12, just like BC was second, now EF is listed second, and then FD is 15. Find the values of x and y, then find the ratio of the perimeters of the two triangles. Ooh, this one's going to use theorem 44.1 because I have a perimeter thing. But it's actually going to be a really easy application of it. And then the next thing I need to do, I need to figure out which two sides I know in both, which corresponding sides do I know the length of both sides so I can figure out the similarity ratio. Well, that's going to be 5 and 15, the last side here and the last side listed here. I know they're corresponding because if I look at the triangles, CA is the same order as DF. Okay. And you might notice, hey, wait a second. D comes first and F comes last. In this one, A comes first. So shouldn't there be AC? Well, remember, segment AC is the same as segment CA. They're just the same way of recognizing the same segment. So it doesn't really matter. All right, let's do this. We're going to do 5 over 15. So I'm going to start with this triangle. This triangle's numerator. This triangle's denominator. 5 over 15 equals, and then let's start with our x term. So we're going to have x squared minus 7. That's an expression that I need to put in parentheses here. Okay. I'm being a little sloppy with how I'm writing these out. I should use fraction bars and make it really easy to see how I'm doing the cross multiplying, but I'm just trying to save time. This is going to be x squared minus 7 over, and what side corresponds to AB? Well, looks like DE, 6. Okay, now, first thing I'm going to do is simplify this fraction. We're not dealing with 5 over 15. We're going to deal with 1 over 3, because 5 over 15 is just 1/3. And then I'm going to cross multiply. 1 times 6 is just 6. And then 3 times x squared minus 7. Ooh, I'm going to have to distribute this 3. It's going to be 3x squared minus 21. And let's just make that an exponent. There we go. Okay, to simplify this, I'm going to add 21 to both sides. 27 equals 3x squared. And then I can divide both sides by 3. 9 equals x squared. And that means that, and I'm going to be very thorough here in my answer, x equals 3 or negative 3. And can I plug in negative 3 for x? What happens if I plug in negative 3 for x? It actually does give me a positive value for that side length. So even if I plug in the negative, I'm not getting a negative side length value because I'm just squaring the negative 3 right away. So I do have to record negative 3 as one of my answers. That's an interesting one because usually we get to exclude it if it's negative, but this time we have to include it. All right, and then now we can do y through the same method. My similarity ratio is going to be the same. 1/3 equals, and in this case, it's going to be y plus 4. Y plus 4. That's the expression over. And then in my denominator, BC corresponds to EF, so 12. Okay, and now if I go ahead and cross multiply, I get 12 equals, and then I have to distribute this 3 again, 3y plus 12. Let's see, the next thing I'm going to do is subtract 12 from both sides. 3y equals 0. Well, 3y equals 0, then y has to equal 0. So x equals 3 or negative 3, y equals 0, and that is the correct answer. Now, the question also is, what is the ratio of the perimeters of these two? Well, the ratio of the perimeters is just 1/3. It's the same as the similarity ratio that I started with. All right, we're on to the next one. Let's do letter C. Figures A, B, C, D, and E, F, G, H are similar. The ratio of their corresponding sides is 3 to 5. That's my similarity ratio. Find the perimeter of EFGH. If the perimeter of EFGH is 45 inches, what is the perimeter of ABCD? Okay, now just have to look at order here. It tells me that the ratio of ABCD to EFGH is 3 to 5. Okay, notice I started with ABCD as my first one. Now it's telling me the second one's perimeter. So I'm going to just put P over 45. I need to make sure I put 45 in the right place in this fraction. It has to go in the denominator because 5 was related to the second figure. So 45 has to be related to the second figure, and they're both in the denominators of their respective ratios there. Now I just cross multiply. 3 times 45, that's going to be 135 equals 5p. And then if I divide both sides of this by 5, this is a tougher, let's see, 5 times 30 would be 150. This is going to be 3 less than that. So it's going to be 27 equals p. And let's see if my quick, don't want to use a calculator trick, worked. 27 inches. Yep, I forgot to put inches at the end, so I'll just write that over here. There we go. All right, letter D. Pentagons ABCDE and FGHIJ are similar. The perimeter of ABCDE is 32. The similarity ratio is 2 to 9, starting with ABCDE as 2 and FGHIJ as 9. What is the perimeter of FGHIJ? All right, so this is going to be 2 to 9, 2 being from ABCDE equals, well, 32 is from ABCDE. So 2 is on the top. 32 has to go on the top over P. All right, so now I'm just going to simplify this by cross multiplying. I'm going to get 2P equals 9 times 32. Here again, we have kind of a tough one. 9 times 30 is 270, plus 9 times 2 is 18. That's 288. So that means that P is going to be 288 over 2. It's kind of an easy number to split in half. 144 and centimeters is our label for that. Let's just double check that we got that one right. Bam.